think it's about time to start. Can someone close the door? Okay, so basically, I believe we kind of finished all the, like, you can say, important contents that I want to share with you by using, for example, the board. And so it's almost about time for you guys to present your presentations. What I'm thinking is that starting from next week, it will be our paper presentations. So let's take a look at who will be the first batch of people to present. If you still remember. Alright, I think this is the order of it. So next week, we have Thursday and Friday, right? So okay, so we will. So each of you, you will have like half hour for your presentation, including Q&A. So which means that we need 6 people to present next week. So someone and Quinyo will be the 2 presenting on Thursday. Okay. And then Li Shan, Zongying, Lu Ting, Amanda will present on Friday. Okay, so that's our schedule for next week. So any question? So like I said, half hour and including Q&A. So if you only use 10 minutes or 10 minutes, 10 minutes or 15 minutes for your presentation, I will ask you questions, or we will have discussions for another like 20 to 15 minutes. Okay, so that's pretty much about it. So and also the other thing is, if you if there are some content that you don't understand when you are reading the paper, you can feel free to like schedule a meeting with me, and so I can help you a little bit. I don't want you to like just present something that you don't understand, or you can say you don't even know what you're talking about. I don't really like that. So hopefully when you're preparing it, if you don't understand anything, then you just email me and then schedule a meeting with me, and let me help you a little bit. Okay. So that will be it. Any question regarding anything? Okay. If not, then that's our schedule starting from next week. Okay. So and if you forgot when you are going to present, then you can try to like figure it out. Okay. Okay, so in this case, for this week, actually, is it too small? All right, for this week, or for today, actually, we are going to talk about the, we are going to go over all the slides to like kind of let you guys know what are the content that we have on the lecture slides, and then there may be some better drawing than what I draw on the board, and also there may be something I missed, and so I can also like share with you guys as well. Okay, so that's what we are going to do today. And in terms of last week, what I heard from the TA is that everything goes smoothly. Is it like that? So on Thursday, I believe you guys take a look at the camera calibration software, and like I mentioned in the class. So most of the currently many people is using that type of software, that Eyewitness Pro, to perform the camera calibration. You can take a lot of photo and then to perform the self-calibration bundle adjustments. So it can directly give you the focal length and also lens distortion coefficients. So that's pretty much like that. And then on Friday, based on my understanding, is that you guys use both 7 and 8, 6 and 7 stereo pairs, and then to measure some points, measure some control points, and then to perform the like orientation modeling to refine the orientation, and then you will measure some time points, and then to perform to create the DM, and then after that you create the also verified images. So basically that's you can say kind of tied everything up through those labs and also link back to what we introduced in the class. So hopefully you can, it can be helpful for you guys. And like I said, in the past, well, this course actually require students to write the program to do everything, to do like the space resection, space intersection, and also replication. That's what we did in the past. But however, nowadays actually people in photogrammetry field actually use lots of tools, and that's a good thing. And also it can actually reduce the loading of this course. So I think that's good as well, because in the future, if you enter the photogrammetry field, like to work and to get familiar with those tools is actually much more important than knowing how to write the program by yourself. In my personal opinion, right now, unless you are doing some research work related to photogrammetry. Okay, so and I believe we have a regulation to say you need to submit a summary report for the labs. So basically, you only need to submit, in my personal opinion, only need to submit two, one for Thursday, one for Friday. Okay, so just like that. In the past, actually, I say we have multiple labs, like space intersection, space recession, also replication, and also calibration. So in the past, it's like separated into multiple reports. But however, well, I think you can combine it together to be like Thursday, the labs on Thursday, and the labs on Friday, and that's good enough. So which means that you only need to submit, each of you only needs to submit two reports to summarize what you have learned and what you have done in the last week. Okay. Any question regarding anything? When is the deadline for that? Actually, I forgot.
The deadline already passed.
Oh, really?
It's November.
Oh, I mean, like that's just for reference. Okay, so.
You didn't say anything about a new one.
Oh, I didn't say anything, but I said about the report, right? The summary report, right? Yes. Okay. So some people not go ahead. That's the honest people. Yes, I know. Okay. So when are you going to submit it? I forgot the regulation. I kind of say remember it's 1 week, right? Or not? No. Okay. Insan, wait. What's the regulation? Oh, okay. 1 week, which means today, right? Yeah. Okay, so I think next week then. Next week, yeah, because it's just a summary report to like say what you have learned and what you have done, and should be fine. Should be fine. And I don't want to like postpone it to the end of the semester because you guys, I believe you guys will work on the homework by then. So next week is the deadline for the summary report for the labs. Okay. So you can, well, just email me the electronic copy. It's fine. Okay? But remember to like let me know who you are actually, because sometimes people don't put their name in the email. Okay. So that's it. Any question regarding that? Okay. If not, then let's go over the slides that we have. Okay, we actually have multiple, well, lots of chapters because originally photogrammetry courses in this program. Actually, we have two courses for photogrammetry. One is the aerial photogrammetry, and the other one is the digital photogrammetry. And then at that time, when I like serving as a professor over here, I combined them together to become one course, and so that I have a little bit of time to teach another course I have, the WebGIS, the CloudGIS. So in this case, in terms of the slides, actually I combine those, the slide, as you can see, we have like 13. Yeah, we have 13 chapters in this course, so it's like a lot. But however, that was originally like spread in well, it was in two courses. But however, I put them all together in this course. So we have many chapters, but however, some of the content are kind of overlapped. So well, let's go over it. So the first nine chapters are actually mainly related to the aerial photogrammetry, and then from 10 to 13 are mainly related to the digital photogrammetry. So let's start from here. The definition over here, where basically just define we use one community which is called ASPRS, one of the most famous international organization in the photogrammetry and remote sensing field. So they define photogrammetry as this, the art and science and technology by using cameras, by using the image taken by cameras to do some measurement. And then that's basically that's the definition of photogrammetry. And then the types of photogrammetry, close range, you already know that, like UAV or using cell phone to do some photogrammetry work, and aerial photogrammetry and satellite. And in terms of application, in terms of application, you can separate them into like the topographic and non-topographic photogrammetry. But the reason for that is because photogrammetry originally was proposed to measure the terrain, to measure the elevation of the terrain. So that's, you can say, kind of like the traditional application for the photogrammetry. But however, nowadays we apply photogrammetry in many fields. For example, archaeology or medical fields, and so on and so forth. So photogrammetry has been used in many other domains, and also, for example, like the self-driving cars, of course, it's also related to the photogrammetry. And in terms of the way you process you process the data, metric photogrammetry means that you care about the coordinates, you care about the geometry and coordinates. Interpretive photogrammetry means that you care about content on the image. So which is more related to remote sensing, actually, in my personal opinion. And then image source, I believe you guys know of them already. Frame camera, push-pull scanner, whisk-pull scanner, and also those are the optical images, and also for the radar images. So those are the image source. Some people actually use the radar images to do some photogrammetry work, which means that to talk about how to also rectify, for example, like how to also rectify the radar image. And as you already know, that radar, the imagery geometry for the radar and for the optical sensors are different. So in this case, their also rectification process is also different as well. So that's also another types of interesting research as well. Okay. And the reason that photogrammetry is important compared to like ground surveying, these are the merits of the photogrammetry. So just take a look by yourself. Non-contact and also other things, fast acquisition and so on and so forth. Those are the good thing about photogrammetry. And this is talking about what's the difference between map and images. So in terms of the map, it's the also graphic projection. So you only have one single scale in the map. But however, for the image, especially here, is talking about the frame camera. So frame camera is using the central perspective projection. And then following the coordinate condition equation. So you have multiple scales on your image. So how to transform from image to map? That's the also replication process. And so that we can utilize those also image and to compare with other GIS data. And here are some special cases. And the first one is talking about if you have a vertical photo and for the flat terrain, then in this case it has the same projection behavior with maps. So maps, it has a single scale. And if you take the vertical photo for flat terrain, then you also only have one scale. So it has the same behavior with the map. But however, and here is about flat terrain, but it's a tilt photo. So here you can link it back to the information that we talked about, which is the tilt displacement. So in this case, you have multiple scales from large scale to small scale, and then in this case, you have a tilt photo and how to transform the tilt photo to correct it to become a vertical photo. You can perform, for example, like 2D projective transformation to do that, which is also the tilt displacement correction as well. And special case 3, here actually is where we can introduce the relief displacement, which is caused by if you have multiple points on the same x and y coordinates, and then if you project it to the image with the central perspective projection, then you will find that they are at the different location on the image. So that distance is the relief displacement. And here is a photo from the traditional aerial photo actually. And from this photo, actually, we can observe multiple things. And one thing is one thing is that as you can see, we have some black corners and also edge over here. And if you pay attention here in the middle of each of the black corner and edge, here is a red cross. It has a small red cross over there. That is the producer mark. Alright, that is the producer mark that we talked about before. So if you link all the producer marks together, then you can define the indicated principal point, which is defined by the producer marks, and which basically means the principal points that we use in the traditional photogrammetry. And that's the first thing that you can observe. The other thing you can observe is that as you can see, the middle part actually has higher exposure. It is brighter than the edge, right? Edge region. So that is a phenomenon called exposure fall off. Did we talk about that? Exposure fall off. 曝光衰减. Did we talk about that? Alright, if not, okay, so I didn't talk about too much about the optics in terms of exposures, what are the factors affect the exposure for a camera. Later on we will briefly talk about that, but however there's a behavior. Say, if you use the camera and to take the photo, then the middle part is brighter than the edge. Why? Because, well, you have more energy, basically, that's the reason. In the middle, you have a lot of light ray that you can pass through the lens. But however, for the edge of the image, then because the angle are different, so you have less